Alrighty. So we're good to go then? All right. Hi, everyone. I'm Zach from Modern Robotics. See me on the camera there? Today, I'm going to show you a little bit of what we just came out with. We came out with a new program. I'm going to show you a little bit about debugging these, and I'm going to do a brief overview. So I'm going to start with a presentation I made, and then I'm going to do a demo, and then we can have questions. And if anybody on the Hangout has questions, please send them in the chat window because I cannot hear you. Thank you. So now I will share my screen. Sweet. All right. Yep. All right. So to start off, we'll do a brief overview. In this presentation, I'm going to have a brief description of the hardware. I will talk about known issues and troubleshooting. I'll talk about a new program, core device discovery, and then I'll have a few questions that were posted prior to this event. So first, we all know that this is an Android system that is run by 2 Android phones or tablets, and they must support OTG. I know FIRST recommends the ZTEs. So the driver station. The driver station allows you to, send. It's basically a dummy app. It talks to the robot controller, gets all the information from the robot controller app. As Modern Robotics, we don't really have any control over the driver station or any connection with it, really. Now the robot controller app, the robot station, this is where you configure all your motors, your motor controllers, your servo controllers, your sensors. This is actually very important. Every controller that we ship out has a unique serial number in terms of the FTDI chip, which is what the USB uses to communicate. So if you swap a controller out, you need to redo your configuration for the new controller because it'll be looking for the other FTDI serial number. If you've ever run into that problem, that's exactly what it is. It's just a configuration issue. And this is also the program that stores all of your Java code, all of your op modes, and that connects directly to the power distribution module. There it is. So the power distribution module. On the power distribution module, we have 6 Anderson power poles outputs, 12 volts, and we have a 20 amp fuse to protect against voltage spikes. And we have a 7-port USB hub. Now this hub is just considered a general USB hub. As you can see in the picture on the very right, there is another power distribution module. You could branch another power distribution module off of it or a generic USB hub if you needed more ports. And this whole module takes between 9 and 15 volts, so you could run legacy equipment with 9-volt batteries on it. The motor controller, which is popping up right now, you can connect 2 motors to it. They have 4-pin encoders and Anderson power poles. There is a 5 amp max per motor, so a 10 amp max total on the controller. The motor controllers, they've been working pretty well. I personally like how they've been working, and we haven't really had many problems with them. The servo controller, kind of basically the same thing you saw last year. It has six ports to plug in servos. It also has Anderson power poles for power and a USB on the back. And that'll run analog or digital servos. The core device interface. Now this is where you're going to be connecting all of your sensors. The core device interface has 8 digital input-output ports. It has 8 analog ports. It has analog outputs from -4 volts to 4 volts, so you can actually do sine waves, square waves, triangle waves, which is really helpful if you have a sensor that requires a different type of waveform. It has 2 PWM outputs. I know some teams like to string up LEDs. That'd be a very good port for stringing up LEDs. And it has 6 expandable I2C ports. And the reason it says expandable is because if you had a header with more I2C ports on it, you can just connect it to one of those, and it's all the same bus. And with that being the same bus, that also means that if you have 2 of the same I2C sensor, they have the same I2C address. You can't use them at the same time. Now, in the program that we came out with, you actually have a very easy ability to change the I2C address, which I will show you when we demo. And the legacy module. The legacy module allows you to connect up to 6 legacy devices to it, whether it be motors and servo controllers, the matrix controller, old sensors, and it is port S5 that can output 9 volts that allows you to use the Hi-Technic or Lego ultrasonic sensor so that you can measure distance. And if you don't have that 9 volts active, the range of it's not as far. And then we also have a whole line of sensors we've come out with. There it is. We have analog sensors like the optical distance sensor. We have digital sensors like the touch sensor, which can also be used on an analog port. And then we have more and more I2C sensors we're coming out with. There was a question about, are we going to come out with an integrating gyro or a gyro? And we just released an integrating gyro. It has an X, Y, and Z axis, and it can return a heading. So if you set your null wherever you set it and you turn 90 degrees, it'll maintain that heading, which is pretty nice for finding your way around the map. And we have a lot more sensors we're going to come out with that we're constantly putting in the works. And then this is just a whole overview of the whole system. It's pretty self-explanatory. It all works pretty nicely together. I have noticed there is a difference between using the motor and servo controllers, the Modern Robotics ones, versus using legacy. In terms of writing your code, you have to set read and write modes, which could be a pain, but with the legacy, you absolutely have to use read and write modes. So there's been some issues, and I don't know if anybody's seen on the first forum lately, Tom Eng made a post about the power distribution module and a couple of issues people are having with it. Some of the troubleshooting that we could do here is when you plug in your power distribution module, plug nothing into it at all, and the first thing you should plug into it's power. Make sure your power is hooked in with correct polarity. Turn that on, and you should see 3 LEDs. The first LED should be the 12-volt LED. That indicates that you have 12 volts going to the system. The 5-volt LED just points out that the 5-volt circuit is on and working, and the 3.3-volt LED does the same. It points out that the 3.3-volt circuit is on and working. If all 3 of those come on, then you can proceed to the next step, which is plugging in the phone. When you plug in the phone or computer, that 4th LED, the USB enabled, turns on. That LED does not turn on until the power distribution module detects a USB host, whether it be the phone or the computer. And it is recommended that you turn the power on first, then plug in your phone if you are having some difficulties. And that actually came from Qualcomm. They recommended the same. So if you're having problems seeing those 4 LEDs, or if that 4th LED there, the USB enable, is flickering, it would be a good idea to contact us at Modern Robotics, support at modernroboticsinc.com. And what we can do is we can help you troubleshoot it even further and see where we can go from there. Another issue people are having with the power distribution module is the cable, the on-the-go cable. The on-the-go cable, the mini and the micro, were never built for robots. They were built for phones. So, you got to take a little extra care when plugging and unplugging these. If you're rough with them, you could damage it. You could make them a little looser, and then when it comes to actual robot challenges, you could be climbing up that mountain, give it a good shake, and the cord could come loose. With that, we also recommend USB strain relief. In the office, we've used rubber bands to just kind of hold them in. We've built little parts out of metal pieces to hold them in. it's really up to you as to how you want to design it. Other known issues with other controllers, we haven't really had a lot of issues. If you're having trouble detecting a controller and you cannot figure out why you can't find it on your robot controller app, we recommend you can plug in every controller directly to the phone or directly to the computer and have that be detected. It doesn't have to go through the power module. So you bypass the power module, and that'll really tell you if it's your controller or if it's the power module. So on the application I'm going to show you in a second here, it'll actually show you the serial number, the manufacturer ID, and everything like that, that will give you information as well as give us information. Some people say that motor and servos aren't working as expected. That's another thing that this application would help you test. There's a lot going on in the Android platform, so to say that it's 100% the hardware is tough to say when you have so much behind that application. So it's a very good test of testing your motors and servos, as well as you can change the I2C address of any of your sensors. So this is what the core device discovery will look like. It has seven spots for 7 devices because we have 7 spots on the power distribution module. You couldn't do an 8th, it just wouldn't show up. There is a spot on there to save the output. By saving the output, it just takes a log file, it makes a text file with all the information that's on there, and when you contact us, we'll request that file, and then we could take a look at what controllers are connected and how they're detected. And it also, once you have modules pop up, it'll provide an advanced button. That advanced button will allow you to test your motors, test your servos, test your sensors. So with something plugged in, you have your first one here. We have the different boxes. Blue means that there's nothing connected. Red means that it's either an unknown device or your servo or motor controller is not powered, so you need to make sure that they're powered. And the green means that something was found. The COM port is relative to your computer and how many things you've had plugged in. Just as a note, and what I've experienced, if you hit COM port 100, it will not work because it goes into 3 digits, and we haven't gone that far. So if you do get to that, all you have to do is just erase some of your COM ports, and it'll take care of that. And then we have the device name. If it pops up unknown device, then again the box would be red, and that would mean something's up with it. Then if you hit the advanced button there, it'll take you to a window much like this. This is the motor controller advanced window. It has 2 motor ports, and it has both encoder ports. Now you can test your motors by running them at constant power, constant speed, or you can run to a position using an encoder value, and you can type in any value and it'll run. We do have some keyboard shortcuts, so if your motors are running and you want them to stop, you can hit escape really quick and it'll stop all your motors from running. What's nice about this motor window, it also tells you the voltage of your battery. It's the only controller that does that. And right now, when that was taken, that was at 12.4 volts. That's really helpful if you can't tell if your battery's dead or not. You can just plug in a motor controller and find out. You can also reset your encoders to 0 if you got them too far and you don't want to wait for it to get back to 0. And there's an update values button. That's when you type everything in, you want the motors to actually move. You hit the update value. I believe enter also works. With the servo controller, we have 6 channels. You just plug in 0 to 255, and it'll go to that position. And that's just that would be the PWM signal there. So you can enable or disable all the servos. You need them enabled, obviously, to make the servos move. The legacy module has, it'll allow you, if it's an I2C sensor, it'll allow you, you can click the I2C button and it'll bring up what the I2C address is of that device. With that, you can type in a register location and register values. So for instance, when I was at Droids on Roids, when I was at their meeting, what I did is we plugged in their system, and they were using legacy hardware, and they had a legacy servo controller connected to a servo. And what I did is I just Googled the old PSD for the servo controller and found the addresses. I found that address 48 was the PWM enabled. So under register location, I type in 48. Under register value, I typed in 1. I hit enter, or I hit right, and it enabled the servos. Then I went back to 42, and I could type in any value I wanted, and the servos were moving right around. So you could even test your legacy equipment with this, as well as like a touch sensor or your ultrasonic. You can read it just by clicking the button read, or you can pull read, where it'll just constantly update what the value is. And the core device interface, this one's got quite a bit to it, but you can test absolutely everything with this. You could there's onboard LEDs that you could turn on and off just to ensure that it is talking. You can even set your PWM outputs and your analog outputs to test, just to make sure those are working as expected. It has analog and digital outputs, and that's really helpful for just checking your sensors and seeing what values it works with, because every sensor reads slightly differently, so you want to make sure you know how it's reading first, and this is a really good platform to test that. With the digital I2C ports, you can plug in a bunch of different I2C devices, hit refresh list, it'll come up with the I2C address and the name of the sensor. And then in the I2C commands, you would type in the address of that sensor, type in the register that you want to talk to, and those registers are all available on our website. And it will spit out a value, or it'll write a value, depending on what you click, read or write. And then this little box here in the middle, the change address, allows you to change the I2C address of any sensor. So let's say you had 2 color sensors you wanted to use for this year's game, and you couldn't use 2 at once. What you would do is you would unplug one of them, because if you have both of them in, you'll change the address of both of them. Plug one of them in. You would type in 3C, because that's the hard-coded I2C address. And if you notice on the cards that your color sensor came in, it says 1E. That was a mistake on my part. I had bit shifted it. But anyway, the actual address is 3C. So you type in 3C as the current address. Type in your new address. I believe it's from 10 hex to F0 hex, or 0F hex. No, 10 or F0 hex, and it has to be an even number. And the box will light up red if it's an invalid I2C address. I'm at the end. I'm at the questions.
Okay. So at any rate, we'll then take your questions and go back in next week.
Okay. Okay. Yeah, so we'll get back to it. If anybody has questions, I can show it again. So we had some questions that were sent in ahead of time, and one of them was, what triggers an emergency stop on the robot? Any sort of disruption in the USB signal will trigger an emergency stop. Now, I just got an email from First, I think it was earlier this week. I got an email from First and Qualcomm saying that they've updated how that loop handles disconnecting from the robot. It'll now, when you disconnect, it'll try a little bit again. That's not active yet in the public release, but it will be. And what that'll do is, if there is a disconnect or there's a shake in the cable, it'll allow it to recover. A lot of teams have been having issues with that, and that is being worked on. The next question is, when you are configuring your robot in the app, why does it not always recognize all of the motor controllers, and how do we fix this issue? So as of right now, if you have all of your stuff plugged into your power distribution module, you connect your phone, and you can't detect everything, you're going to have to continually hit scan for every controller you have in. It's not just a one-hit scan and it brings everything up. So you do have to scan for every controller. And if you're having problems with a particular controller that you cannot get this one motor controller to hook up, try connecting that directly to the phone. We also recommend downloading the core device discovery and connecting everything in that way. I had one customer who said they couldn't find their modules at all. They hooked it into our program and they found all of them. So it turned out that they actually had issues with their robot controller app. They reloaded it and it worked fine. So that was all the questions that we had beforehand. I'm going to ask if there's any questions now, and I will minimize this so I can get back to the Hangout. Hello, Hangout. There's the chat. So if anybody in the chat has questions, please type them in, and I will address them. And does anybody here have any questions so far? Fantastic. Anybody? All right. So what we can do now is we can get into testing. I have a question. All right, what's your question? We will wait on the question. By the way, if anybody brought their laptops, I have our program on here as well as the documentation if you wanted to put it on your computers. Question is, how do we get to the screens you were showing before? Yeah, the presentation. So that was probably a little broken before. What I can do is I can show you the screens again after I demo. If you have the ability to, the screens that I have are all also on our website. I actually just kind of stole the pictures from our website. So if you go on modernroboticsinc.com/core device discovery, it'll take you right to the page, or if you just go to the main page, it's right up on the top there. And you click that, it'll bring you to a page that has 2 links, a little description, and some pictures on the bottom. One of those links is the exe to download. We will be coming out with the Mac version. We just have to fully test it, and then we'll probably come out with that next week. But there's a Windows version right now, as well as documentation on there, and then underneath are pictures of each individual page. And then it says, okay, for the troubleshooting pages, do I just plug my devices into my computer? Yes, you do. So you can, what I like to do, because I'm efficient, I like to plug my power distribution module into the computer and hook up all the controllers at once so I can scan all of them. You could hook them in individually, and if you're having trouble still connecting all of your controllers to your computer with your power distribution module, plug them in one at a time. And it is another good thing, and it takes a little while. I was here for about 10 minutes while Windows Update installed the drivers for these. So you do need to make sure that the drivers are installed for all of these and COM ports are issued before running the program. And once you have them recognized by your computer, it's as quick as plugging it in, and just like that, you can start using the application. So once your controllers are recognized by your computers, you won't have to wait any longer. So I hope that answered your question. If not, just say so. And in the meantime, I will throw up a different camera. Mm-hmm. Oh, look at that. Alrighty. Look at that. Got some local teams here. All right. So here I have my nice test rig that I made. We've got a servo controller on here, a motor controller. We've got a servo. Put a motor underneath. We've got our legacy test. We got our legacy and our core device interface. And I will show you how I walk through it. Now, if you're sitting there at home, you can't obviously see me. So my recommendation to you is to have that website open just so you can at least see the screen that I'm referring to. Now, why is that blue? Can I get that to not be blue? When I closed the PowerPoint, it didn't like that. The application. What application is that, you ask? The application is the Core Device Discovery application. It's on the modernroboticsinc.com website. modernroboticsinc.com, yes. Don't forget the Inc. Otherwise, it'll be the wrong website. I know. Sorry if that was loud. I tried to cover it. We're just waiting on our projector here.
So, Owen, I remember we had a problem with this summer. Were you part of the solution?
So we'll get started with this demo in just a second. So when I shut the PowerPoint down, it just stopped sharing the screen. And I don't want to mess with it too much.
There's an option on here that will allow us to mess with having this back and forth. I'm not sure.
Yeah, why not? Let's hit a bunch of buttons.
I think that changes around the projector type.
Duplicate. Maybe. I got to figure out how to open the Hangout back up. Oh, there it is. Okay, so good. We're back. So feel free to keep typing questions. So I have the core device discovery up. I have everything plugged into it. And I'm going to power my power distribution module on. Everything turns on. I click refresh. Let's try that again. I tried to screw it up. So I click refresh, and I have 4 modules pop up. And device number 3, as you can see, it says it's on COM port 5. It tells you the serial number, which is the FTDI serial number. That number is very important to us. But it doesn't tell you a revision number, a manufacturer, or a device name. And what that means is it's either a broken board, a broken module, broken controller, or I just didn't power it, which I just didn't power it. So now if I plug power in and click refresh again, everything should pop up. So everything pops up here. What I will show you first is the motor controller. So, oh, it's nice and warped. So if I click advanced, we have our motor controller window pop up. And I have my motor connected to motor port. So if I set it at a speed of 50 and I hit enter, my motor runs. Now I know my motor runs. If I hit escape, it sets the motor speed down to 0. Now if you see my encoder is at 26,000. If I type in my motor speed again, let's say I want it to be 100, but this time I say run to position, it'll make the encoder window in. So let's say I want to make it 0. I type that in and then I hit enter, and now it'll go all the way down until the encoder hits 0. And then if you really want it to be quick and you're sick of waiting, you just hit reset encoders and it sets everything back to 0, with the exception of the speed. So you can switch between speed and power while you're running it. And we can see that my battery is at 13.3 volts. So this is very good for testing your motors to see if you have any flaws with them, or to see if your encoders are plugged in correctly. Do we have a question? Yeah.
So they're not seeing.
Right, and I told them that they couldn't see that, so I told them to open it up if they could, yeah. This red cable runs from the power distribution module to the computer. I took it from work. It's mine. Oh. All right, so now we will, it's a USB to USB mini. Now we'll test the servo, and I believe I have plugged my servo into servo port 2. So if I go to servo port 2, it's defaulted at 128, which is right in the middle. I go to 0, servo enable, show the camera as well. Oh. Update values. 1 second. So that moves that. Oh, yeah, that's right. I forgot the servo I grabbed. I broke it at one point, and it has I can't go past certain limits. But I can bounce between values. You can test out all different values and see where your servo sits at different values. And it's just as easy as typing it in and hitting enter. And then once you disable the servo, you can notice that you can now freely rotate it, versus when it's enabled, I can't move it at all. So that is the servo controller. Do I have any questions from the Hangout yet? Do I have any questions here yet? Okay. Moving on to the legacy module. the legacy module. Now, a good way to test your legacy module, just to make sure it's working, and I'm going to make sure the camera can see this, is the LEDs. There are 4 LEDs on the legacy module, which you can light up independently. And if you guys can see them over here, they're on the bottom. And I can just turn them on and off the check boxes. And what that allows you to do is, if that's working, you know for a fact that your legacy module is communicating. And now I brought that's a Hi-Technic or a Lego touch sensor. I'll plug it into, let's go to S3. So I plug that into S3. And if on sensor port 3, if I pull the read, it's pulled high, so it's sitting at 1021, and if I hit the button down, it drops down to 183. It should technically drop down to 0, but the values aren't perfect, and the hardware is built to know that. So as you can see, I'm getting a live feedback knowing that this sensor is working. So if you have any sensors that you're unsure about, this is a good way to test them. And if I didn't want to pull read, I could also just read them every time, but it's better to just check that box. So that is the legacy module. You can also test your motor and servo controllers. They do have to be powered in order to be tested. Now the fun one, the core device interface. So on here we also have a blue and a red LED. Oh, nobody can see it. So we have a blue and red LED that you can turn on and off again to check and make sure that it's communicating. I don't have anything here with me today to test the PWM outputs or the analog outputs. And by the way, the PWM cannot handle a servo. It does not have enough voltage to handle the servos. So please do not try to run a servo on there. Analog and digital ports. I brought an optical distance sensor. I will plug that into one of the digital ports. Let's go with that one. So now that I plugged it in, you can see, oh wait, it's an analog sensor. Probably be better to plug in an analog port. So now as you can see, I am getting values. That A3 that's getting values there, that's just it's just picking it up. Can you define pull read, please? So a question on the Hangouts is, can you define pull read? And what pulling is it's a term used in coding when you're pulling for information. Basically, your program's doing nothing but sitting there waiting to get information. Whereas if you had the button to read it, it reads what the current value is. By pulling read, it's basically a while loop that's just sitting there saying read, 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 read over and over again. So that's what pull read does. Pull read is very useful when you're testing a distance sensor or something like that, so you can actively move it and watch it read as opposed to hitting the button every time you've moved the sensor. So I hope that answers your question about pull read. If it does not, feel free to ask again and I will define it a little bit more. And then, so that is the optical distance sensor. You can see that works, and that'll work with any sensor. I just didn't bring any more. And now, to show you some of the I2C stuff, I brought 2 color sensors. And these color sensors, if I am correct, are going to show up as compasses. So I connect my 2, color sensors, and I refresh the list, scans them, still scanning them, and it comes up as compass. And see how it only comes up as one of them? It's because they both have the same I2C address. And the reason it comes up as compass is we just had a mistake in our system where this shares the same ID as the compass. It is being fixed. It's nothing that breaks it. It's just a simple number mismatch in our IDs. So now if I unplug one of the color sensors, and over here on change I2C address, I type in 3C, and I change the address to, let's do 24. So now I click change address, now it pops up as 2.4. So if I plug in the other sensor, and refresh the list, it'll pop. Now you see both sensors. Now both sensors can be used independently. So if I were to go here now, over to the I2C command window, and I type in address 2.4, because that's what I made it. Register location 4 for most sensors is the generic read heading, or for the instance, the color sensors, it's the color number. So if I hit there and I go to pull read, I don't know which sensor it was, I think it was this one. So I need something of color. Look at that, I have an orange sticky note. So right now it's reading 0, which 0 is read for either the color black or empty space. If I put it up on the orange piece of paper, it is kind of dark in here. We have turned the lights off so that we could see the projector, but it's reading 10, which is around an orange red or a yellow red, so it'd be around an orange. If I had something blue, I could connect that. Want to hand me that cup? I don't want to rip the headset out. Thank you. So now if I hold it up to the cup, I am getting a value of 3, which 3 and 2 are around the blue. So this is a good way to test your colors, test your color sensor to make sure that they're working and that the numbers pop up. And by the way, the LED is on the color sensor. That means it's in active mode, which means it is really good at reading surface colors. It is not good at reading colored light. You need to be in passive mode for that. In order to go into passive mode, I will answer that question in just a second. In order to go into passive mode, you'll have to go to the command register, which is register 3, and just type in whatever command it is to set it to that mode. And I don't know that offhand, but it is on our website. So let me answer some of the questions popping up on the Hangout. First question, are those Modern Robotics sensors or third-party sensors? These are all Modern Robotics sensors that I brought with me, except for this one. This sensor here is a Hi-Technic or a Lego sensor. It's one of the two, but it's a touch sensor. NXT touch sensor, that's what that is. But all of these, anything that you see that comes in a nice little housing like this is a Modern Robotics sensor, just like this one. Most third-party sensors don't have housings like the Adafruit sensors. They're just bare boards. All of our sensors, all of our controllers, everything comes in a plastic housing. And we will be selling a lot more sensors as we can get them out as quick as we can. And the next question, is there a list of numbers and their corresponding colors, or should this be done right through the trial and error? On our website, if you go to modernroboticsinc.com, click Sensors, and then go to Color Sensor, there's every register that you can have access to and talk to, read from, write to, as well as a color number chart. That color number chart is specific for these color sensors. I do not know if it'll work with a third-party color sensor. And that color chart shows you, it has black, white, it has 0 through 12, I believe, is all your colors, and then it has 13 through 16 or 17 that it's more of a grayscale kind of colors. It's really bright colors. So there is a color number chart on our website that you can see the different colors. Now, what's nice about the FTC game this year is you have blue and red, and on the color number chart, those numbers are nowhere near each other, so it's not like you're going to accidentally read one or the other. The next question we have, what should we do about our core power module disconnecting once we have confirmed there's a secure connection between our phone and the module? Let me read that again. What should we do about our core power module disconnecting once we have confirmed there is a secure connection in our phone?
Another way they asked me via text that is core distribution to this emergency stopping while our wires are still tight. It was not phone.
So the other question that I got across the room was that my memory's good, but not that good.
I know.
The core distribution module keeps emergency stopping while wires are still tight. Was not the phone connector. So an emergency stop can happen whenever any cable comes loose. So if you have, and it's not caused by motors or servos, but USB connections. So if a USB connection shakes loose on absolutely anything, it'll go into an emergency stop. That is more on the end of the USB cables you're using and the application itself. Now, if you're having a problem detecting the controllers on startup, where that USB LED doesn't come on reliably, or you're coming up and you hit scan and the USB LED's on, but no controllers pop up, that is something that you're going to want to contact us about, because that is something that we can either potentially fix or replace. So that would be one of those. In terms of the emergency stop, which I see you just put again, in terms of the emergency stop is caused by a disruption in communication. Try swapping cables. The on-the-go cable, that micro cable, is a very, very small cable. I mean, you could hold that into the phone and it could still be wobbly. So I would suggest trying other cables, and if that's still not it, please contact us at support@modernroboticsinc.com, and what we can do is we can help you troubleshoot it even further, and then we could see if we need to get it in for repair or replacement. So I hope that answers your question. If not, please ask, and I will explain even further. The next question: are the numbers the same no matter what the module, no matter what the mode? Are the numbers the same no matter what mode the color sensor is in? Yes, the numbers are the same. The difference in the mode is this LED right here. Active mode has the LED on, passive mode has the LED off. And you're going to want to use passive mode for the FTC game, finding those colored lights. Active mode will just light it up and it'll pop up white every time. So the color number chart does stay. Okay, yes, please do contact support, and I will either be me or Colton that answers. Do we have any questions here in-house?
Are we going to change the address we want to use more than one color?
Okay, so the question is, you have to change the I2C address if you want to use more than one color sensor? Yes. So you can't use two of the same I2C sensors with the same address, because it'll look at them both as the same. So yeah, so you can, it has to be an even number. So this one's 3C. You could just bump the next one up to 3E.
Where can I find these addresses?
I'm sorry, where can you find what?
The addresses, how can we?
Oh, the addresses? Well, when you open up this application, you plug in your sensors and you click refresh list, it'll pop up with what the current address is. So let's say you changed the sensor address a couple of times and all of a sudden you don't remember what the default address was. You can plug it in, find out what the current address is, go on our website, which will tell you what the hard-coded address is, and you can just change it back to the hard-coded if you wanted to. And you can change those addresses. I wouldn't suggest changing them all the time, but yeah, you can change those, and there's no damage done. And this, I looked at the code, the Android code, the Java code that it was written to change I2C devices. I can't even understand it. It is complicated. This is easy. You push a button. I like it. Fits my style. So, do we have any other questions on the chat, Google Chat? And then do we have any other questions here in-house? Yes.
In the event of a power disruption or a cable coming loose, like a USB cable, will it shut down the entire system or just that motor controller?
Okay. So the question is, in the event of a wire coming loose, does it shut down just that controller or the whole system? And to answer that, in the event of a wire coming loose, the whole robot will go into an emergency stop. And that was put in place because, let's say a connection does come loose, but the power is still on and the code's still cranking. If your motors are still running and all of a sudden it's disconnected and you can't communicate with it anymore, instead of chasing it down, the whole thing just goes into a stop. And like I was saying before, Qualcomm has written a new way to handle disconnections, where it's going to try a couple of times to reconnect. So if it does come disconnected temporarily, like it shakes loose and pops back in, which happens, it'll it'll do much better at handling that disconnect. Other than that, and that isn't actually out yet, so don't expect to go see that just yet. But always read patch notes. When they come out with the patch notes, always read the patch notes, and that'll tell you what the latest updates were. Somebody asked, can we ask about a programming issue as in legacy sensors? I don't have a lot of experience in the Java programming. You can ask the question. I just can't guarantee that I can answer it. We do make the hardware, and we came out with this program because we found that the Android has a lot of overhead to it. So the question is there any way someone could explain the Java code for switching from read to write mode for the legacy module? I figured I'd try it. Yes, there's actually a code called NXT teleop. Open up NXT teleop, and that actually has a line of code that you can copy and paste that sets read mode and write mode. The reason I know that is because I had to personally use it in a program that I wrote, and also when I was visiting the Droids on Roids team, we had looked up that code and tried it out. That code is the code that will best show you how to use legacy equipment. It doesn't have absolutely everything in there, but it has enough to kind of get you started. And in case anybody doesn't know, if you download your, FTC App Master, right? If you download your FTC App Master folder, wherever you put it, if you double-click that folder, inside there's going to be a folder called Doc, D-O-C. Open up the Doc folder. In there, there's going to be another folder called Java Doc. Open that up. Inside there's going to be a bunch of different HTML links. All of those HTML links have different names, and they all point to different stuff, but that is absolutely everything that the SDK has. So one of them is constants. You'll see every constant that is in the SDK. The ones on top, all classes, that'll be the most helpful. It tells you every class function call you can make. I know, it's just a really good place to go and find out what's available. If you're trying to write to a color sensor, it shows you everything that's available for that color sensor. So the expanded question now is, I've been writing that program a few times. Which part should I be copying? You'll actually see in that code, in caps, it says read only, write only. That is the important line of code. Read only, write only. That's where it switches over. And you do have a little bit of a disadvantage using the legacy equipment because you have to use that line of code in there. And if it doesn't make the full switch, so if you have your write only mode and you go to write to the controller and you go right back to read only, it might not even see that because it might not switch over in time. So learning how to use delays and waits or pauses or loops are really helpful. Also, switching it ahead of time would be useful. But if you're still having trouble finding it, it is in the NXT teleop code, and it is absolutely everywhere in that code. And if you're still having trouble finding it, you can email me personally. I'm Zach, zac.z, at modernroboticsinc.com if you guys have any questions that aren't necessarily meant for support. And I can show you where that is. Does that line of code switch to read mode or write mode? Yes. I can't remember the whole line of code, but yeah, it does switch to read mode or write mode. And you can test that using a couple of old legacy sensors. I believe I use the touch sensor to test my reads and write modes. Also, motor controller. That would be a good one to test, reads and write modes, because you can write motor powers and you can then read motor encoder values, so you'd know if you actually made the switch or not. But yeah, and another good place to get information on coding is the forums. I know a lot of people love the forums. As Modern Robotics, we don't necessarily moderate those forums at all. We do read them from time to time. But that is the best place to go for coding. Best place to go to hardware is us directly. So I hope I answered your question. If not, we can discuss more after. Does anybody else have any other questions in-house or on the chat? Okay. So the question is, can you plug the controller modules into the computer directly and bypass the power distribution module? Yes, and that is recommended. As much as it is useful to plug them into the power distribution module and test them. If you are having trouble with a particular controller, why add another variable to the mix? Plug that controller straight into your computer, and only one device will pop up, but you'll be able to test that one device. So yes, every module can be plugged directly into the phone or the computer. However, the motor and servo controllers need to be powered in order to communicate and work. I don't have any other questions in the chat as of right now. Anybody else have any questions in the chat? Everybody's muted. Any other questions here? Yeah, it says, does that line of code switch to read mode or write mode? And yes, it does. I don't, I might have it on me. Yeah, it's in the NXT teleop, and that's the only piece of code that I know that has that bit of information. Everything else is designed for the new hardware. By the way, for those that have Tetrix building systems and you're finding that it's very difficult to connect the controllers to your robots, that's because they were designed for the matrix hole patterns. So they will fit on Tetrix. They will mount to Tetrix. I've seen a lot of people use Velcro. Velcro is great, but not the best. You could still find holes that match up. Okay, so the question now is, which mode does it switch to? If you type in write-only mode, it switches it to write-only. If you switch it to read-only mode, it'll switch it to read-only. So if you have write-only mode, every bit of code after that is set to write to the controller. When you put in read-only mode, every bit of code after that sets it to read from the controller. So if you try to make a write and the last thing you said was read-only, you aren't going to be able to write. Just nothing will happen. Just like if you try to make a read and it's in write-only mode, you're not going to be able to read. You are welcome. So back to the hole patterns. They are designed to fit matrix pieces, so don't be alarmed if they don't fit your Tetrix. We also have the matrix kits on our website, so we design them for matrix. Any other questions? No? Okay. Any other questions on the Hangout? Don't all jump at once. All right. So if there are no more questions, then we can conclude this Hangout here. And if anybody has any further questions that you think of later on, you say, oh, I should answer that, because believe me, it happens. My boss leaves the office. I have a question that I now have to wait to ask him. So if you do have any other questions, feel free to email us. You can either email us at support, or you can email me personally at zach.z. Zach is Z-A-C. I spell it the cool way. So feel free to email me or the support line, and we'll be more than happy to help you. We do not normally answer high-level coding issues, not because we can't, or I guess it's because we can't. We don't really dive into the high-level coding yet. Soon enough we will, but as of right now, we have a main focus on the hardware. So if you have any hardware questions, best place to come is to us, and software questions, best place to go is the forums. So, alrighty. Well, I'd like to thank everybody for giving me your attention and listening to me ramble on. It's been a learning experience, and if you guys ever encounter any problems or see anything new, feel free to contact us as well, because we always like ideas. It's something that we can write down and possibly add into the next version or carry on to someone else. So if anybody has any ideas or observations, feel free to let us know. All right, thank you very much, and I hope you enjoyed the show. Bye. So, should I stop it?